Hi students, in this video we are going to see the example 6.12. The question, if A vector is equal to minus 3 I cap minus j cap plus 5 k cap, B vector equal to I cap minus 2 j cap plus k cap, and C vector is equal to 4 j cap minus 5 k cap. Find A vector dot B vector cross C vector. Okay, so what are the values are given? First one, A vector, that is minus 3 I cap minus j cap plus 5 k cap. Next one, B vector, that is I cap minus 2 j cap plus k cap, and C vector equal to 4 j cap minus 5 k cap. Okay, to find A vector dot B vector cross C vector, first let we find B vector cross C vector. Okay, so the cross product is nothing but the determinant of the values I cap, j cap, k cap. So next row, B vector, the coefficient of B vector, so 1 minus 2 1. Next one, C, here 0 4 minus 5. Okay, so let me expand this term. I cap into minus and minus plus, so 10, 5 to 10 minus 4 minus j cap into minus 5, this is 0 minus 0, plus k cap into 1 4s are 4 minus 0, so minus 4 I cap minus into minus plus 5 j cap plus 4 k cap. So next we have to find A vector dot B vector cross C vector. Here A vector is minus 3 I cap minus j cap plus 5 k cap dot, next B cross C value, that is minus 4 I cap plus 5 j cap plus 4 k cap. Okay, so the dot product, so minus 3 into minus 4, minus into minus plus 3 4s are 12. So next minus into plus minus 1 5s are 5. Next plus 5 4s are 20. So 32 minus 5, which is equal to 27. Hi students, in this video we are going to see the example 6.12. The question, so here three vectors are given. The first one, A vector, which is equal to minus 3 I cap minus j cap plus 5 k cap. Next B vector equal to I cap minus 2 j cap plus k cap. Next C vector equal to 4 j cap minus 5 k cap. Okay, here we have to find A vector dot B vector cross C vector. We know that this value is nothing but the scalar triple product. Okay, scalar triple product. So we can write in box product A vector, B vector, C vector. Okay, so the box product value is nothing but determinant value. Okay, so first row, the entries minus 3 minus 1 5, second row 1 minus 2 1, third row 0 4 minus 5. So next let me expand this term. So minus 3 into minus minus plus 2 5s are 10, this is minus 4 minus here minus 1, so minus minus plus 1 into 1 5s are 5 minus 5 minus 0, so next plus 5 into, so last element 1 4s are 4 minus 0. Okay, so minus 3 into 6 plus 1 into minus 5 plus 5 into 4, so then minus 18 minus 5 plus 20, so it is equal to minus 23 plus 20 equal to minus 3. So this is the value. Next example 6.13. The question, find the volume of the parallelepiped whose coterminous edges are given by the vectors. So three vectors are given. Okay, so let me take in let a vector equal to the first one 2 I cap minus 3 j cap plus 4 k cap. Second one b vector equal to I cap plus 2 j cap plus minus k cap. Next c vector equal to 3 I cap minus j cap plus 2 k cap. Okay, we know that the volume of the parallelepiped is nothing but the box product of a vector, b vector, c vector. This is the formula. Okay, so the box product of a vector, b vector, c vector is nothing but determinant value of the entries. Okay, the first row entry 2 minus 3 4, second row 1 2 minus 1, third row c value 3 minus 1 2. Okay, so next 2 into 2 2s are 4, here minus 1, minus minus plus 3 into 1 2s are 2, minus into minus plus 3, next plus 4 into minus 1 minus 3 2s are 6. So 2 into 3 plus 3 into 5 plus 4 into minus 7, so which is equal to 6 plus 15 minus 28. So 21 minus 28 equal to minus 7, but the volume should be positive. Okay, so we have to take modulus, so the volume value always positive. Okay, so then we can say that the modulus of box product of a vector, b vector, c vector is nothing but 7. The unit is cubic units. Next example 6.14, show that the vectors, three vectors are given, we have to show are coplanar. Okay, so first one, let a vector equal to I cap plus 2 j cap minus 3 k cap, b vector equal to 2 I cap minus j cap plus 2 k cap, and c vector equal to 3 I cap plus j cap minus k cap. Okay, we have to show coplanar. Coplanar means volume should be 0. That means box product of a vector, b vector must be 0. Okay, so let me find the first one, box product of a vector, b vector, c vector. Okay, so the determinant of the first row entries 1 2 minus 3, second row 2 minus 1 2, third row 3 1 minus 1. Okay, let me expand this term. So 1 into minus 1 into minus 1 plus 1, this is minus 2. Next minus 2 into minus 2, this is minus 6. So next one minus 3, 1 to 2, this is minus and minus plus 3. So 1 into minus 1, minus 2 into minus 8, minus 3 into this is 5. So minus 1 into 1 minus 1, this is minus minus plus 16, this is minus 15. So 16 minus 16 equal to 0. Okay, so the box product a vector, b vector, c vector equal to 0, which means a vector, b vector and c vector are coplanar. So hence proved. Next example 6.15, the question, if three vectors are given are coplanar. Okay, find the values of m. So first let me take the first vector a vector equal to the values 2 I cap, next minus j cap, next plus 3 k cap, B vector equal to 3 I cap plus 2 j cap plus k cap. Next C vector equal to I cap plus m j cap plus 4 k cap. Okay, given that A vector, B vector and C vector are coplanar. Okay, so already the statement is given, the three vectors are coplanar. Here we have to find the value of m. Okay, we know that A, B, C are coplanar, which means box product of A vector, B vector, C vector is equal to 0. So box product is nothing but the determinant values. The first entry 2 minus 1 3, second row 3 2 1, third row 1 m 4 equal to 0. Okay, so here let me expand this term. So 2 into 4 2s are 8 minus m, next minus into minus plus 1, here 3 4s are 12 minus 1 plus 3 into 3m minus 2 equal to 0. So 16 minus 2m, 1 into here 11, so plus 11 plus 3 3s are 9m, here minus 6 equal to 0. So let me add the m values. So 9m minus 2m, so we will get 7m. So next 16, this is 11, so 27 minus 6, so 21 plus 21. Okay, plus 21 equal to 0. So we need m value. So 7m is equal to minus 21. So m equal to minus 21 by 7. We cancel the 7, 3 7s are, so m equal to minus 3. So this is the value of m. Next, example 6.16, the question show that 4 points, here 4 points are given. We have to prove lies on the same plane. Same plane means we have to show coplanar. Okay, same plane, that means it's nothing but same surface area, that is same plane, that means coplanar. Okay, so let me take the points. Let A, the point is given 6 comma minus 7 comma 0, and B point 16 comma minus 19 comma minus 4. Next point C, that is 0 comma 3 comma minus 6, and last one D point 2 comma minus 5 comma 10. Okay, so these are in the form of points, coordinate points. Okay, now I am going to convert these points to vectors. Okay, so the position vector of A, so let OA vector is equal to 6i cap minus 7j cap, k cap into 0 becomes 0. Okay, so next OB vector equal to second one 16i cap minus 19j cap minus 4k cap. Next OC vector equal to, this is 3j cap, I cap becomes 0, so minus 6k cap. Okay, so finally OD vector equal to 2i cap minus 5j cap plus 10k cap. Here we have 4 position vectors. Okay, now I am going to form the lines AB. Okay, AB vector equal to OB vector minus OA vector. OB vector value is 16i cap minus 19j cap minus 4k cap, minus OA value is 6i, so minus 6i cap, here minus 7, so minus and minus plus 7j cap. Okay, if we separate this value, 16 minus 6, so 10i cap. So next minus 19j, here plus 7j, so minus 12j cap. Okay, so minus 4k cap. This is AB vector. Next I am going to find AC line. Okay, AC vector. This is another vector. So OC vector minus OA vector. What is OC? That is C 3j cap minus 6k cap minus OA values minus 6I cap minus into minus plus 7j cap. If you add the I cap value here, minus 6I cap alone. Next j cap. So 7j, 3j plus 10j cap. Next minus 6k cap. So this is AC vector. Next one AD vector. I am going to find the line AD. So AD vector. OD vector minus OA vector equal to OD value is 2I cap minus 5j cap plus 10k cap minus OA value minus 6I cap minus and minus plus 7j cap. So 2, this is minus 6, so minus 4I cap, so next j cap minus 5, this is plus 7, so plus 2j cap, next plus 10k cap. Okay. So to show these points on the same line, that means coplanar, we have to find the box product AB vector, AC vector and AD vector. If the values, box product value is equal to 0, we can say that these points are lies on the same plane. That means coplanar. Okay. How to find the box product value? We know that we have to find the determinant value. In the first row, we have to enter the AB values, the components. Okay, so 10, minus 12 and minus 4. In the second row, minus 6, 10, minus 6. Okay, next AD component, minus 4 plus 2, 10. Okay, now I am going to take the 2 as common in the first row and the second row and third row also. Okay, so 3 times I can take 2. So simply I can write 2 cube. Okay, 2 into 2 into 2. If I take the 2 in the first row as common, then I will get 5 here, minus 6, this is minus 2. This also will be reduced, so minus 3, 5 and minus 3. So last row also minus 2, 1, 5. So 2 cube is nothing but 8. We know that. I am going to expand this term. 5 into 5 5s are 25. Here minus into minus plus 3. So next to minus into minus plus 6 into minus 3 into 5 minus 15. Here minus into minus plus, but another minus also we have. So minus 3 to 6 to the 6. Next one minus 2 into here minus 3. This is minus and minus plus, 5 to are 10. Okay. So finally we have 8 into here 8 into 5 into this is 28 plus 6 into this is minus 21. So here minus 2 into 7. Okay. So which is equal to 8 into this is 140. Here minus 1666, 6 to 12, 126. Here minus 7 to 14. Okay. So 8 into 140 minus this also 140. So 140 minus 140 becomes 0. 0 into anything 0. Okay, 0 into 8 0. So we can say that AB, AC and AD are coplanar. Okay. So AB vector, AC vector and AD vector are coplanar. Okay. That means the points A, B, C and D lies on the same plane. Okay, this means coplanar. Okay. Next let me see the example 6.17. The question: if the vectors A vector, B vector, C vector are coplanar, then prove that the vectors A vector plus B vector, B vector plus C vector, C vector plus A vector are also coplanar. Okay. So what is given? The given A vector, B vector and C vector are coplanar. So A, B, C are coplanar. Coplanar means we know that box product of A vector, B vector, C vector is equal to 0. So this is noun result. Okay, we have to prove that A vector plus B vector, B vector plus C vector, C vector plus A vector are also coplanar. Okay, are also coplanar. To prove these three vectors are coplanar, we have to find the box product. Okay, to find the box product. The box product is equal to 0, then finally we can say that these three vectors are also coplanar. Okay, so to prove these three vectors are coplanar, we have to find the box product of A vector plus B vector, B vector plus C vector and C vector plus A vector. Okay, A, B, C are three vectors. If you add two vectors A plus B, so is also another vector. So likewise B plus C also another vector. C plus A is also another vector. Okay, so we have to find the box product of these three vectors. We know the definition of box product. Box product is nothing but the scalar triple product. Scalar triple product. What is scalar triple product? One cross product and one dot product will be there. That means A vector plus B vector cross B vector plus C vector dot C vector plus A vector. This is scalar triple product. Okay, scalar triple product contains one dot product and one cross product. So the first bracket should be contained for the cross product. Okay, for the cross product. So let me take the cross product for every elements. So A vector cross A vector, next plus A vector cross C vector and B vector cross B vector, next plus B vector cross C vector. Okay, dot C vector plus A vector. Here B vector cross B vector. The cross product of the same vector equal to 0. We know the result. Okay, cross product of same vector. Okay, same vector must be 0 vector. So it should be 0. Okay, so we can left this one. Remaining will be A cross B and A cross C and B cross C. Okay, so A vector cross B vector plus A vector cross C vector plus B vector cross C vector, remaining vectors dot C vector plus A vector. Next I am going to take the dot product. Okay, for each one. So A cross B, A vector cross B vector dot C vector. Okay, dot C vector and dot A vector also. So plus A vector cross B vector dot again A vector, because plus here. Okay, next one A cross C plus A vector cross C vector dot C vector, again with A vector cross C vector dot A vector, plus the last one B vector cross C vector dot C vector, plus the finally B vector cross C vector dot the last one B vector cross C vector dot the last one A vector. Okay, here ABC 1 dot 1 cross here. This statement is the box product of A vector, B vector, C vector, because it is scalar triple product. Okay, this is scalar triple product, so we can write in box product A vector, B vector, C vector. Look here, A 2 times here, so box product of A B A. Okay, in the scalar product, if any two vectors are identically equal or proportionally equal, then the box product value will be 0. We know the result. Okay, in this scalar product, any two vectors are same, the result will be 0. Okay, so here 2a, okay, 2a 2 times here, so this is also 0. Here C 2 times, so this product value is also 0. So finally we have the last one, plus B cross C dot A. Okay, this is also scalar triple product, and this vectors are in cyclic order, BCA cyclic order. Okay, if it in cyclic order, we can write in order ABC. We know the result. Okay, BCA is the cyclic order, so we can write in box product A vector, B vector, C vector. Okay, so we have ABC box product plus ABC, so we can write 2 times of box product of A vector, B vector, C vector. Okay, 2 into, already we know the result, box product A vector, B vector, C vector value is 0, so 2 into 0 becomes 0. Okay, finally we have proved the box product of A vector plus B vector, B vector plus C vector, and C vector plus A vector equal to 0. This, which means we can say that A vector plus B vector and B vector plus C vector and C vector plus A vector are coplanar. So this is the proof. So hence proved. The last example 6.18. Okay, the question, if A vector, B vector, C vector are 3 vectors, prove that box product of A vector plus C vector, A vector plus B vector, A vector plus B vector plus C vector equal to box product of A vector, B vector, C vector. So to prove this, first let me take the LHS. Okay, left hand side, the values box product of A vector plus B vector, A vector plus B vector, A vector plus B vector plus C vector. So this is in the scalar triple product. So already in like the previous problem, we can take in one cross product, A vector plus B vector cross A vector plus B vector. So the last one dot A vector plus B vector plus C vector. So let me take the cross product. So A cross A vector cross A vector, next plus A vector cross B vector, so next plus B vector cross A vector, next plus B vector cross B vector. Okay, dot A vector plus B vector plus C vector. Here A 2 times here. Okay, say cross product of same vector is equal to 0, and the cross product of B vector cross B vector is also 0. So final we have A vector cross B vector plus here B vector cross A vector, my dot A vector plus B vector plus C vector. Okay, so next we have to take dot product with the every vectors. Okay, so A vector cross B vector dot A vector, so A cross B dot A vector plus, so next with B vector, so A vector cross B vector dot B vector plus, so next with the C vector, so A vector cross B vector dot C vector. Okay, so next with the B cross A plus B vector cross A vector dot A vector plus, so next B vector cross A vector dot B vector plus B vector cross A vector dot C vector. Okay, in this case we can cancel some terms. Okay, so look the term a 2 times here, so this scalar triple product value becomes 0, so we can neglect this one, and B vector and B vector, so 2 times here also 0. So here ABC, okay, ABC, this is the scalar triple product, so we can write in the form of box product of A vector, B vector, C vector. So next A 2 times here, so becomes 0, so here also B 2 times, so becomes 0. So next one BAC, okay, this is box product of B vector, B vector, A vector, C vector. Look the term, this box product, the value is BAC is not in cyclic order, okay, ABC and BCA is a cyclic order, BCA. The next to B is C, BCA, it's cyclic order, but BAC is not in cyclic order. This is not cyclic order. So A vector, B vector, C vector, we can write in cyclic order, but we have to put sign, minus sign here. So minus into A vector, B vector, C vector. If it in cyclic order, no need to take negative. If it is not in cyclic order, we should put in negative sign. Okay, so minus into A vector, B vector, C vector. Okay, so it becomes